Okay, so we're going to look at the AP Calc BC free response questions from 2000, not 2007, 2017. All right, I'm going to focus on the non-calculator questions because your exam is meant to be done without a calculator, or at least, it can be done without a calculator, so they're not going to be focusing on calculator-based problems. And then just another note is that you have no parametric or polar calculus on your exam. Right, that's different from other years. I think that means that you don't have to solve equations like x of t equals something and y of t equals something. You don't have to do calculus with this, but I think that position, velocity, acceleration is fair game because it's covered on the AB exam. So I think that's fair. All right, so I'm going to focus on the non-calculator stuff, and then if we have time at the end, what we can do is go back and set up some of the calculator ones and then just not solve them. Okay, so let's go ahead and take a look at the first question. By the way, if you have any questions or comments, you can type them here in the chat box. All right, so just everybody kind of just say hi in the chat box so I know you guys found it. Perfect. Okay, fantastic. You guys are used to this. Okay. All right, so here we have a function f. It's differentiable on the closed interval, and it satisfies, we have an initial value condition. That's cool. Here we have the graph of f prime. So this is the derivative graph, and then if we wanted f, we would integrate it. Okay, and so what we want to do is find the values of f of 6 and f of 5. All right, so the way that we want to do this is we want to take advantage of our initial value, okay? So there's our initial value. We want to take advantage of that. And the way that we're going to do that is we're going to say f of negative 6 is equal to the value of f of negative 2, which we're given, and then plus the integral from negative 2 to negative 6 of my derivative. Right? Does that make sense to everybody? So where I'm starting plus the integration of the rate of change. Okay? And does that make sense? Yes, no in the chat box? So you're starting somewhere and then you're adding. Perfect. Okay, and now we're gonna go ahead and we can compute that integral using the area, but I'm gonna flip this into proper form here first. All right, so remember that you want the lower bound on the bottom. So negative 6 to negative 2, that's a little less stressful. All right, but then this becomes a subtraction when you flip the bounds. All right, and then we can go ahead and compute this as the area of that triangle. So that is 1/2 base times height, all right, which is 1/2 the base is 4, and then the height is 2. So that is 4. Everybody please remember to mute their microphones if possible. Fantastic. Okay, great. So there's that. So then if we go ahead and we use our initial value, I get 7 minus 4 is 3. Does that make sense to everybody? So we can say that f of negative 6 is 3. Awesome. All right, if we go ahead and look at f of 5, all right, we're going to compute it the same way. All right, f of 5 is going to be where we want to start, plus the integral of negative 2 to 5 of my derivative. All right, so same procedure. Now a little more interesting because I have 2 areas that I have to deal with. All right, so we can find the area of my semicircle, All right, that is pi r squared would be the whole circle, but it's a semicircle, so I'm dividing by 2. All right, what's the radius of that circle? Looks like 2 to me, right? So 4 pi over 2, which is 2 pi. Now, not totally correct because it's below the axis, so I'm going to put a negative sign in there, all right? And then I need the area of the triangle, this one, from 2 to 5. And that again would be 1/2 base times height. All right, the base looks like it's 1, 2, 3. And the height is 2, so this is then positive 3, it's above the axis. Okay, so then if I want to put that together, f of 5 is equal to the 7 that I'm starting with, minus 2 pi plus 3, so that would be 10 minus 2 pi. All right, and I think those calculations are pretty fair given that you don't have a calculator. I think that's okay. All right, does anybody have any questions on how we found any of that? Okay, awesome. Remember, you will get a copy of the recording. I don't know how or when, but I know you will. Okay. All right, on what intervals is f increasing? Somebody want to give me a clue how to do that? We are increasing when f prime of x is greater than 0, right? So, fantastic. So it looks like we're increasing on the intervals. Now we can be careful here because we can use the closed brackets, okay? So -6 to -2, all right? And then in union with 2 to 5. A quick question, yes, please. On this year's Calc BC exam, there won't be a subscore, so do you think the free response will cover A-B concepts as much? I think that BC Calc is A-B Calc plus some stuff on applications of integration and sequences and series. So if it were me, I would be thinking that probably one is going to be an A-B-like question and the other is probably not, if I'm a betting person. Why the bracket? Because we're closed here. And we're closed and it's not 0. Right? And then at least with the -2, you're at 0, so it would be an open bracket. And then again, 2 would be a open bracket. So open here because there's 0. Okay, and then let's go ahead and just talk about where we're decreasing. So decreasing is when f prime of x is less than 0, right? So the question, would it be safe to use open brackets? You would actually not get it correct if you put an open bracket here. So we have to be a little careful. Okay, so decreasing from -2 to 2. Okay, and then open because there's 0. This one is closed because it's non-zero. All right, so everybody okay with that question? Devil's in the details a little bit. Okay, so now this is, I think, the toughest question of the bunch here. Find the absolute minimum. All right, so remember that when you have questions like this and you have closed intervals, you have to check the endpoints. All right, so we can say that the absolute minimum is going to either, occur at a critical point or at the endpoints. And you always have to check those endpoints. I actually think that's pretty tricky. All right, and we can check the critical points though. All right, so if I look at the critical points here, -2, 2, I'm doing a line test. All right, we go from positive to negative and then back to positive. So positive to negative, negative to positive. So I could have a minimum at 2. That is possible. All right, so possible minimum. And then we have to go through and figure out like what our values are. Okay, so if I looked at a table here, I would have x, f of x. All right, so I check my endpoint. So -6, we happen to know that the value is 3. All right, and then we know that at -2, it is 7. That would be a max. And then 2 and 5. All right, so I have to check the 5. No, I have to check the 2. So here we figured out the 5 already. This is 10 minus 2 pi. And now we just have to figure out if this value is more or less than 10 minus 2 pi. So how do we go about doing that? Isn't the absolute minimum whenever the integral goes from -2? So the minimum occurs at the maximum. Yeah, we do have to check the values, but you have to check the endpoints. That's the point. All right, so to get the value at 2, we would do f of -2 plus the integral from -2 to 2, right? Of f prime of x dx. So then this is 7, and then we had calculated the area of the semicircle as -2 pi. So this is 7 minus 2 pi, right? And then we can see that this is less than 5. Okay, so we have to be real careful with that though. All right, so we've seen questions where you could have the minimum on the endpoint. All right, but we can say here that the absolute minimum is at f of 2, all right, and then be careful, they ask for the y value, all right, which is 7 minus 2 pi. All right, does anybody have any questions on that question? Great. Okay, so now could we justify our answer by saying we use the candidates test? I don't know what the candidates test is, so that may be something that you like a second derivative test. Is that what you're asking me? I went back and checked -6 because it's an endpoint, and I checked 5 because it's an endpoint. I just added the -2 because I knew the value. So I think candidates test may be something that is particular to your teacher. In general, the justification would be that you check the values. We all have our own nomenclature. Okay. So what we want to do now is find f double prime of -5 and 3. All right, so -5, how would I go about doing that? So f double prime is the slope of that line. We will for 3. At least we know here that like this is a continuous line. All right, so we can find the slope for that one. F double prime of -5. I'm gonna go ahead and use the points -2, 0, and then 6, -6, 2. Let me finish this one, and then we'll get to 3. All right, so 0, -2 over -2 minus the -6. All right, so -2 over 4. So f double prime of -5 is -1/2. Okay, and then for the 3, you're 100% right, is to take the limit as x approaches 3 from the left, and see here that I have f prime of x here. All right, and see that this slope is a, well, let's see. So it would be f prime of x minus f prime of 3 over x minus 3. Let's see, and then we would get, what would we get? 2. And then the limit as x approaches 3 from the right. With -1. All right, and then, so again, the slopes. All right, and then these do not match. So therefore, f double prime of 3 does not exist. So 100% right. You can do a more rigorous proof if you'd like. All right, I think that saying it's a corner is also fine. Okay. Any questions on that question? When explaining why it does not exist, would showing our work like that count? Showing work in math counts. Would we get points for saying it's not continuous? It would depend on what you said is not continuous. F is continuous because it's differentiable. Differentiability implies continuity. So not 100% correct there. Plus the derivative is also continuous. So I don't know, does that help? So you probably got it wrong if that was your justification. Perfect. Okay, so we'll go on to question 4, which is a differential equation question. All right, so this is something that would not be on the AB exam and would only be on yours. Okay. Good questions, guys. Really good questions. Keep them coming. We love questions. Okay, at time t equals 0, a boiled potato is taken from a pot on the stove and left to cool. Great. The internal temperature is 91 degrees Celsius, and the internal temperature is greater than 27 for all times t. Okay. The internal temperature of the potato can be marked by this function, and they give us an initial value. So we have a differential equation with an initial value. Write an equation for the line tangent to the graph of h at t equals 0. Okay, so we are given, everybody agree that this is h prime? So h prime of t is -1/4 h minus 27. So we can use this to find h prime of 0. All right, now we have to be careful. Do not plug in 0 for h. All right, h is your initial value, okay? So -1/4 of 91 minus 27, and I'm not very good at math in my head, so we're gonna do that on the calculator. So -64 divided by 4 is -16. Okay, so there's your slope. And then we can do y minus y1 is mx minus x1. All right, and so remember, y minus 91 is equal to -16, and then x minus 0. All right, so y minus 91 is equal to -16x, and if I wanted to simplify, I can. All right, so now, by the way, for you guys, especially on this year's exam, you can leave things in an unsimplified form. So you do not have to go as far as getting it into like slope-intercept form. It is perfectly okay to leave your answers in this form, all right, especially if you're not confident with your arithmetic skills, okay? Totally fine. All right, even fine to leave your answer in this form, okay? Okay. All right, and then the rest of the question, use the equation to approximate the internal temperature, so we can just use our equation. So let's see, so y is equal to 91 minus 16 times 3. So that's 91 minus 48. And again, remember, you do not have to simplify this year. Or any year, actually. Okay. Does anybody have any questions on part A? Would it be useful to set up x as equaling time? I would say yes. Good question. It is time. So yeah. Great. All right. So I'm gonna move on. All right. So use the second derivative to determine whether our answer is an overestimate or an underestimate. So first thing we want to do is get the second derivative. All right, so dh squared dt squared is going to be equal to, now we have to be careful, remember you want to do implicit differentiation when you have these guys. So it's -1/4. Right, but it's not just -1/4. All right, you have to put in dh dt because you are taking the derivative of that h. All right, and then we know what dh dt is, right? It's the differential equation itself. All right, a little weird if you haven't seen this before. Okay, and then so we got 1/16 h minus 27. Okay, and then how do we figure out if this is an overestimate or an underestimate? So we know that h has to be greater than 27 because they told us that for all time, right? And so what does that mean about this? This means that this is always positive, right? So therefore, dh squared dt squared is greater than 0. So what does that tell us about our graph? It means our graph of h, what does this mean? Concave up. Therefore, your estimate, your derivative, is an underestimate. So if we were concave down, then it would have been an overestimate. Okay. Does anybody have any questions? Everybody clear on this step? Why you're taking the derivative of h? Awesome. Okay, so then now we get to solve the differential equation. All right, so for t is less than 10, an alternative model is to satisfy this differential equation. What we want to do is solve that. All right, so what we're going to do is do what's called separation of variables. All right, and I want to get the g's on one side and the t's on the other side. All right, so I'm going to multiply through by dt and divide by the g. All right, the g minus 27. So dg over g minus 27 to the 2/3 is equal to negative dt. All right, and then now that you have them separated, you can integrate both sides. All right, the integral of this is going to be, let's see. Okay, so we are integrating g minus 27 to the negative 2/3. All right, so I get g minus 27 to the positive 1/3 divided by the 1/3, which is multiplied by 3. And then that is going to equal, we integrate the other side, negative t plus c. Okay, and so I generally will solve the initial value problem at this point. It gives me less room to make mistakes. So I'm going to plug in my value to figure out what c is. Everybody clear on why I put a constant of integration? Okay, great. Okay, so let's go ahead and solve for c. All right, and so 3 times, let's see, 91 minus 27 to the 1/3 is equal to 0 plus c. So 91 minus 27 is 64, to the 1/3 is 4. So 3 times 4 is equal to c, so therefore c is equal to 12. All right, and then from there we can go ahead and give an expression. All right, everybody with me? Now be careful with what they asked for. So they asked for g, so I've got to solve this thing for g. All right, so 3g minus 27 to the 1/3 is equal to negative t plus 12 if I divide by 3. And then cube it. And then I get g of t is equal to 27 plus negative t plus 12 over 3, that whole quantity cubed. So that's my expression. So check. And then based on the model, what is the internal temperature at 3? So then we can find g of 3, which is 27 plus, let's see, 9 over 3 cubed. So 27 plus 27 is 54. Okay. So also remember that, let's say you get stuck on a problem and maybe you didn't get the correct expression for g of t. Please don't forget that they will give you a point if you evaluate your function correctly. So even if you get the complete wrong answer for this one, if you plug in 3 correctly, you will get a point for solving for g of 3. Does that make sense? When you plugged in 91 to solve for C, how did you know to plug in 91? They gave you the initial value that G of 0 is 91. So I plugged in 91 and 0. So I plugged in both. All right, let's say they had said G of 1 is 82. All right, then I would have plugged in 82 and 1. All right, does that make sense? So that came from the initial value question. The initial value. No problem. Good question. All right, everybody good? Happy differential equations? Awesome. What do you think will differentiate between a 5 versus 4? So, all right, let's talk about it's a good question. I think that a very slim margin is going to differentiate between a 5 and a 4. But let me answer your question a little more directly, all right? So, if we look at their scoring guidelines, I don't know, but I can tell you what they gave points for. Now they may like give more points over the course of the question, perhaps. We'll see. All right, but so for the first one, you got a point if you got the slope, you got a point if you got the tangent line, and then you got a point if you got the approximation. All right, so there's that. And then for B here, you only got 1 point if you said it was an underestimate. All right, that was it. They didn't give you a point for getting the derivative correctly. So that may be something that they could change. Okay. And then for C, there was a lot of points here. So you got a point for the separation of variables. You got a point for the antiderivative. You got a point for using the initial value condition and solving for C. All right, you got a point if you wrote the equation correctly. And then you got a point if you found G of 3. All right, so again, what's going to differentiate might be a point. So you want to make sure you write out all of the work, if that makes sense. Hopefully that's helpful. And then again, remember, if you're not confident with your arithmetic skills, 100% okay to leave it like that. To just plug in the numbers and say, screw it, I'm not gonna get an answer. That's 100% correct. All right, make the graders do the work to figure out if you got it right. That's what they get paid for. Okay, so we're going to go ahead and do this problem. I believe that determining whether the series converges or diverges is in the scope of this exam. All right, they do say that most of, what they call that chapter is on the exam, so I would be prepared for it. Okay, so let f be the function defined by this thing. We want to find the slope of the tangent to the graph. So that's kind of an AB-like question. We have to go ahead and find f prime of x. Do you think that the unit for Taylor and Maclaurin is on there? I believe so. So they did publish what they said is on the exam, and it looks like everything is on there except for parametric and polar. So you don't have to worry about that, but you do have to worry about the series. No problem. Okay, so I am going to go ahead and rewrite this. Hopefully correctly. I think it's also a good guess. It's a guess, right? So I'm f prime of x, I'm going to go ahead and use the power rule and the chain rule. I personally failed my telepathy exam, so I don't know. So I'm just going to, if it were me, I would study everything. All right, and then we have to make sure we take the derivative of the inside. All right, and so I should get -3 4x minus 7 over 2x squared minus 7x plus 5. All right, and then we want to find f prime of 3. So -3, and then 12 minus 7 is 5 over 18 minus 21 plus 5 squared. If it were me, I would probably leave it at that point. But if we work it out, it's -15 over 4. So again, remember, it's totally okay to just plug it in and leave it. All right, does anybody have any questions on that first one? Okay. Just in case we need it again. All right, so what we want to know is for part B, okay. So we want to figure out the critical points here. To find the critical points, I just take the derivative, set it equal to 0, and solve. All right, this obviates the denominator. So we got -3, 4x minus 7 is 0. And then 4x minus 7 is 0, so x is equal to 7/4. All right, that's our critical point, and then we want to figure out if that is a maximum or a minimum. Do you want to be careful to have 0 over 0 as a solution? So in general, you can get rid of the denominator, but it is good to check. So you want to check the roots of this? We can check the roots of that. So what he's asking is, do we want to check the roots of the denominator? And technically you do, but generally no. Okay, so then what we want to figure out, so if I check the derivative, I usually just do like a quick line test here. And if I pick something less than 7/4, perhaps 0, then I get a negative times a negative, which is a positive. And if I check something greater, let's say 10, hang on a second. So if I plug in 10, then it's a negative. So this is a local max. And the question is, do you get points taken off if you don't check the roots? And no, so they gave you a point if you got the 7/4, and they gave you a point if you showed that the derivative changed from positive to negative and you had a maximum. Okay. Any other questions before I erase? Is the pace I'm going fine for finishing? Well, so again, I don't know how many parts there are going to be to the exam, but I would assume so. So we've gone over 2.5 questions. No, we did 3, 4. Yeah, 2.5 questions in 40 minutes. You guys are going to get 2 questions in 45. So probably about right. Okay. So using the identity, they did the partial fraction decomposition for us. That's very nice. We want to evaluate this thing, or show that it diverges. Okay, so let's start with what this is. So not 8, infinity. All right, so we have an improper integral. All right, so 5 to infinity of f of x. What you want to do is take a limit as some dummy variable goes to infinity. I usually use t. All right, so from 5 to t of my function. All right, and they gave us the partial fraction, which is nice. So I can go ahead and plug that in. I think that they removed improper integrals. I didn't get that memo, but somebody can check their site. Gotta be a faster Googler than I am. Yeah, please. Okay, and then, all right, so then integrating this thing, we get the limit as t goes to infinity of 2 and then ln 2x minus 5 over 2 and then minus ln of x minus 1. And then we want to go ahead and evaluate that from 5 to t. All right, and then if we wanted to make our lives a little easier, we can use log rules. And note that this is 2x minus 5 over x minus 1. All right. And then I plug in my bounds. So I get ln of 2t minus 5 over t minus 1 minus ln of 5 over 4. Okay, so what is up with this one? So what is the limit as t approaches infinity of that first one? Anybody know? All right, so just, yeah, good. ln of 2, just the ratio of the leading coefficients there. So ln of 2 minus ln of 5/4. That's why I think that this is fair game. You know, it brings in some of the limits. You got ln of 5/8. All right, and so then by way of points, just so you guys know, you got a point for just writing the antiderivative, you got a point for putting in the limit, and then you got a point for the answer. All right. So this one converges to a number. Where did you get the FRQ? So if you Google AP Calculus BC free response and then a year, it'll pop up. So this is the 2017 one. If you want to try another one, there's like 30 years of them out there. Okay, last one. So now we can do a little seriesing here. Okay, so determine whether this series converges or diverges, state the conditions. Okay, great. So now this happens to be the one that we just did, right? So we just integrated this thing. So what test do you think you want to do? Probably the integral test, right? Just, you know, a little commonsensicalness there. All right, since we just did the integral, we can say that we know that the series converges by the integral tests. Hang on, we're going to state the conditions there. Because the integral of, f of x there, dx, converges to a fixed point, right? So converges to ln of 8 over 5. Now we have to state the conditions for the integral test. So what were the conditions for the integral test? It has to be continuous on the interval. It has to be positive, and it has to be decreasing, okay, on your interval. Can we use the limit comparison test? Yeah, we can 100% do that, and let's do that. So this was one way to do it, and we'll use the suggestion to do the limit comparison test. All right, so so if it were me, I would be thinking about comparing to 1 over n squared. So we can compare to 1 over n squared. So I know that this thing is greater than 0, and 1 over n squared is greater than 0 for n greater than 5. And then let's do the limit comparison test. Okay, and when I do that, I get 3 halves. So therefore, I know that the series, okay, and I know that the limit of this guy converges. Therefore, since this comes to a number and this converges, therefore this thing converges. So therefore your series converges by your limit comparison test. So that's also perfectly fine. Okay, and then what are the conditions? So you have to be positive, so you have to be greater than 0, and you would either compare to something that converges or compare to something that diverges. So does that make sense? So if you're greater than what you converge to, you're going to converge by the limit comparison test, or less than what you diverge to. So yeah, perfect. Okay, awesome. So let's see if we can get through the last one. Why does it need to be positive? That's just one of the conditions. They either need to be both positive or both negative. I can get a list of the tests and the conditions for you guys and have Troy send it out. I have a good little flow chart. I just have to find it. Yeah, I'll have Troy send that out. He's the guy that's doing all the heavy lifting, sending out my stuff. Yeah, I'll get that to you guys. Okay. All right, so we'll go over the last one. Now, I'm not sure that the error bounds are on there anymore. Like, I don't think that you're going to get an error bound question, but we can still go over it. I think it's probably still useful. Okay, so here's our last question. It looks like, okay, let's see. 10.2 is geometric, 10.5 is harmonic and P series, cool. 10.7 is alternating series, ratio test, so basically all of it. And then if you have to do Taylor, then you have to do Maclaurin, right? It's just Taylor centered at 0. So more or less all of it. Okay. A function has derivatives for all orders. The derivatives satisfy the conditions above, cool. And we know the Maclaurin series converges, awesome. Show that the first 4 non-zero terms of the Maclaurin series for this thing, right, the general term. Okay, so what we want to do is go ahead and figure out what our derivatives are, right? Now note that this is the Maclaurin series, so you're kind of given them. All right, so what is f of 0? Well, I don't have a constant term, so it's 0. All right, what is f prime of 0? Well, it's 1. All right, and then f double prime of 0 is -1 times 1, which is -1. And then f, my primes are getting crazy here. All right, so this is -2 times -1. Everybody seeing where I'm getting this? Remember that this is supposed to be 2 factorial, 3 factorial, right? And then your fourth derivative looks like it's -3 times 2, because again, this is supposed to be 4 factorial. So that is -6. All right, and so then our first 4 non-zero terms would be, so our 0 plus 1x over 1 factorial, minus 1 over 2 factorial x squared, plus 2 over 3 factorial x cubed, minus 6 over 4 factorial x to the 4th, and then that just gives us this. All right, and then if I wanted a general term, all right, I have to write it out. I have to see it. These were never intuitive to me. Okay, so it looks like it's alternating. So -1 to the n plus 1, or n minus 1, that's okay too. X to the n over n. Everybody agree with that? So that first term would be positive. Second, yeah, that's right. Okay. So there's my series. Everybody follow? Yes, no, maybe, kind of? Getting tired? All right. Okay, so next little bit, we want to figure out if this thing converges. And we want to know if it converges, do you not have to? So that is the general term for the series. You can put the summation, that's fine. That's 100% fine. Okay, so we want to determine if this thing converges or diverges. So does it converge or diverge? All right, so if x is equal to 1, I get the sum n equals 1 to infinity of negative 1 over m plus 1 over n. So what do I do with this? So everybody agree that this is a harmonic series? All right, so this is a harmonic series, which is not going to converge absolutely. All right, because the 1 over n diverges. All right, but now because you're right, so because it's an alternating series, so awesome. Your terms are decreasing. All right, the limit as n approaches infinity goes to 0. So you can say that the series converges conditionally. All right, so that's what they're looking for. I'll make sure to get the flow chart out to you guys. All right, and then I just want to make sure we go over C. I'm fairly confident that D is not going to be on the exam, but we'll see. Okay. Write the first 4 non-zero terms and the general term. So we want to take the integral of our series. All right, so t minus t squared over 2 plus t cubed over 3 minus t to the 4th over 4 plus dot dot dot. And then I want negative 1 to the n plus 1 t to the n over n. All right, I'm taking the integral of this thing. All right, so t squared over 2 minus t cubed over 6 plus t to the 4th over 12 minus t to the 5th over 20. And then this thing becomes negative 1 to the n plus 1 t to the n plus 1 over n times n plus 1. All right, and then essentially when we go from 0 to x, all of these t's become x's. All right, so I'll just say sub in x for t. Okay. Does anybody have any questions on that? That one's not too terrible. Okay, can we just start with x? So technically you don't want to start with x because it is it's a function. They wrote it as a function of t and you're integrating with respect to t. So if you started with x, they would probably mark it wrong or only give you partial credit. Technically, that's not correct. Okay. This is the fundamental theorem of calculus. Well, one of them. Okay.